Okay, so this one there's three questions or three parts to one question. The question says, a neon sign has a 240 volt power supply and uses a transformer to increase the voltage to 12,000 volts. So the first question is this a step up or a step down? When you look at this, you're going from 240 to 12,000. So you say, oh, it's increasing, therefore it is a step up. So I'm going to write that there, step up. Pretty easy so far. Okay, you look at the second question or part B, and it says if the transformer has 125 turns of wire on the primary coil, how many coils are on the secondary? So even before you start this question, you'll say, okay, I remember looking at the notes, and I will say there has to be way more turns of wire on the secondary coil because this is a step up. So I'm going to start with the formula. So the original formula from the notes, if you look at them, goes NP over NS is equal to VP over VS. So number of coils primary divided by number of coils secondary is equal to voltage of the primary divided by voltage of the secondary. Now, if you rearrange this equation, you get NS, because that's what you're looking for. Number of coils on the secondary is equal to NP VS divided by VP. Now, do you have all this information? Yes. Okay. So NS is what you're looking for, number of coils on the secondary. Number of coils on the primary you have, it is 125. So you go 125 times voltage of the secondary, right there. You have 12,000 times 12,000 volts. Okay, divided by your VP. So your voltage primary, if you look up here, it said it is 240 volts. So you will divide it by 240 volts. Okay, when you do the math, you get 6250. Now, remember we're talking about significant digits. You go back to the original question. 240 has 3 digits, 12,000 has 5 digits. The lower number is 3. Therefore, your answer should have 3 significant digits. So your answer actually becomes 6.25 times 10 to the 3 coils. So that's a lot of coils of wire. Okay. We move on to the third part of the question, part C. It says the power supply requires 25.0 amps of input. Okay. What is the output current? Okay, so when you're looking for current, current is the letter I. So if you check the notes, there is a formula for current. So I'm going to write it down in case you're not looking at the notes or don't have the notes right in front of you. So you get VP IP is equal to VS IS. Move this up a little bit so you can see it. Okay. So VP is voltage primary, IP is current primary is equal to voltage secondary times current secondary. So when this question is asking about the output current or your IS. So when you rearrange the formula, you get IS is equal to VP IP divided by VS. So looking at this formula, move the camera. Current secondary is equal to voltage primary times current primary divided by voltage secondary. So you have all this information from the previous parts of the question. Okay, so you're looking for IS. You have your VP, voltage primary. If you remember from the beginning of the question, it is 240 volts. So I go 240 volts, and I multiply that by my current primary. That's given in part C. That's 25.0 amps. So I go multiplied by 25.0 amps divided by my voltage secondary. That's the huge number we saw in the beginning of the problem, the 12,000 volts. So I go 12,000 volts. So when I do the math, I get an answer of 0.5 amps. Now, when I look at the question, 25 has 3 significant digits. Okay, so therefore your answer needs to be in 3 significant digits. Therefore, you need to change this answer to 0.500 amps. And that would be your final answer.